Hi guys, I hope you're doing absolutely great so far. Welcome to this course on concurrency. And in this course, we will talk about the terms, the very first thing, because it's a lot of term that we come across when we talk about concurrency. And we have about 7 to 8 terms, that is synchronous, asynchronous, queue, thread, serial, concurrent, and a bit confusing one, that is parallel, also known as parallelism. Now, why are we looking at the terms? Because we need some sort of understanding, not 100%, but some sort of understanding to get started with our examples, which will bring 100% clarity. So starting off with the first one, that is synchronous. When we talk about a piece of code, for example, there is a function and it has a few lines of code. The way this function will be getting executed, it will get executed on a thread, and when it gets executed it will happen line by line. So if this function has 5 lines of code, then the first, second, and third, and so on will be the way the execution will happen. The thread will start its execution and will not stop execution until it reaches to the end. Now this is the execution that happened in one go. When it comes to asynchronous keyword, the execution doesn't happen in one go. If it has 5 lines of code, the execution will start, the thread will start the execution of this asynchronous function, and it will execute first, second, and third line, but then it will suspend the execution to do some other tasks or to run some other piece of code, because that piece of code is important for the execution. And then once it is done, the thread will come back and resume the execution of this asynchronous function. So the remaining lines of code, that is the fourth and fifth line, will be executed then. And that is the difference between synchronous and asynchronous. It's a manner in which a thread executes a piece of code. Now, when it comes to queue and thread, thread is really a core. If we have a quad core processor, let's say, then we have the 4 cores in it. So we have 4 threads. And if say we have MacBook M3, it has about 10 to 12 core processor. Not sure at the moment, but as many as the cores are in your CPU is equals to the number of threads we have. Now, thread is where the piece of code gets executed, but queue is something where you put the piece of code for dispatch. So the queue is just a place where you are putting a piece of code to dispatch this piece of code for execution on a thread, or a thread take controls of this task or a piece of code on the queue and executes it. When it comes to serial, concurrent, and parallel, this is something that we will look further in the upcoming videos as we go through the concepts. Now that we have some understanding on this, we can start off with the very first thing, that is how the execution of a piece of code happens. So let's get started with the example. First, we will see a normal synchronous function whose lines of code will be executing by the thread in a synchronous manner, in the sense line by line. And then we will take an asynchronous function. But before we take an asynchronous function, we'll understand how many ways we can write a asynchronous function. So there are total 3 ways. One is we use completion handler, that is the escaping closure, and we will use the method data task of the URL session there to make the API call. So we'll talk about the second one, that is the delegate callback, and the other method, that is the async await. So these are the few ways we can write an asynchronous function. So we will start off with writing one asynchronous function with the very first way, that is using the completion handler or escaping closure. And then we will understand the problems with it and how to solve it using result type and future. So along the way, we will understand these problems and how to solve it and what is the best way to solve it. That is, we'll talk about the third way of writing asynchronous function, that is async await. So this gives us a lot to look into and understand with the sequence of problem, solution, problem, solution. So we'll take an example of making an API call to the server and fetching an image. Now this image, we will receive it in the data, and the data will be then used to create an image locally. We'll create the UI image, and once we created that UI image, we will transform it into a smaller size. To that we are calling thumbnail. So let's get understanding on what we are writing first. So we will name the method fetch thumbnail. It has four operations. The first is we will have the string, that is the URL string, and we will prepare that string using a method thumbnail URL request. Once we have the URL request as the output of the method, we will use this URL request as an input to the parameter width so that we can use this URL to make the API call to the server. And to make the API call, we are using the data task method. Once the API call has been made, we will receive the data, that is the response. Now we will use this data to create the UI image using method called UI image, and we'll pass the response data to its parameter. That would be the third operation. The output of this method would be an UI image, and that UI image is what we are using to prepare a thumbnail. That is nothing but a smaller size of that image. So we'll take that image and pass it to the method prepare thumbnail. The parameter is off here, to which we'll pass that image. Once this method is done, we will receive an image which is again of type same as that of image, but the size of this thumbnail image would be smaller. So we have these four operations here. Now each of these operation depends on the previous one's result. That means they should be performed in sequence. The first one, once it is performed and the result is the output, that will be utilized as the input for the second method, and the output of the second method will be data that will be utilized as the input to the third method. And similarly, the output of the third method will be utilized as the input of the fourth method. So it is important for the four operations to happen synchronously or one by one fashion. Now, some of the operations return very quickly. The first and the third one are the two methods which are going to return the URL request and the UI image very fast. But the rest of the two, that is the data task, second method, and the fourth prepare thumbnail, is going to take some time. It takes a while to download the data that makes up an image, and rendering a nice looking thumbnail from it requires a device to do some expensive work. That's why the SDK provides asynchronous function, and these two function hence needs to be asynchronous. When we use the data task method, this is a asynchronous method provided by Swift framework, and prepare thumbnail is again the method provided by the framework, and it is also so we will write the code for fetch thumbnail method here. But before we do that, let's talk about the main thing that we were discussing, that is the execution of the synchronous code on a thread versus the execution of asynchronous code on a thread. So we will take this prepare thumbnail method. So just imagine you have a method fetch thumbnail, but it does not contain any code of the first, second, and third operation. It has only the code for prepare thumbnail. So we have a method fetch thumbnail which has only one method called inside it, which is the prepare thumbnail. Now SDK provide two forms of this method, that is synchronous and asynchronous form. So right now you see this method has two parameters of, and the second is completion handler, which means this is one of the way we can identify that this method is asynchronous method. And the SDK provide one more form, the first form, that is the synchronous, which does not have this completion handler. So both the forms, synchronous and asynchronous, will have the same name, but the completion handler will be there only in case of asynchronous method. Now let's take this example where fetch thumbnail has only one method call. The method is prepare thumbnail, and how these two SDK forms, the two forms of the method gets executed on a thread one by one. So when you call a regular old method, that is the synchronous method, your thread is blocked. So in the method fetch thumbnail, there is a synchronous method prepare thumbnail. It doesn't have the completion handler, which means it's a synchronous method. So the thread gets blocked waiting for the function to finish. Until the function is finished, the thread cannot do any other work. And once the execution is done, the control of the thread goes back to the fetch thumbnail method. That is the rest of the code inside the fetch thumbnail method. But in contrast, when it comes to the asynchronous method, it does not block the thread. So we have the fetch thumbnail, it is start executing, and the prepare thumbnail has the completion handler, which is indicating that it is asynchronous form of the method prepare thumbnail. So it does not block the thread. When it runs, your thread is free to do other work as well. It can suspend the asynchronous method and do other work, which is indicated with these blocks here. And once the prepare thumbnail execution is finished, it will notify you by calling its completion handler. Now, SDK provides a lot of asynchronous method. Completion handler is one way to notify, the thread will notify the asynchronous method. Some of the method relies on delegate callbacks. Some are marked as async so that they just return a value. Once the completion handler is called, the fetch thumbnail is where the control of the thread goes back to. That is the rest of the code inside the fetch thumbnail method. Now let's see this inside a code. So we have the fetch thumbnail method here, and we are having ID and a completion handler. When the fetch thumbnail is going to perform all the four operations, that is to prepare the URL, make the API call, get the data, and the third operation is to use that data to create UI image, and the fourth operation to use that UI image to create a thumbnail, that is the smaller form of the image. Now once all the four operation is done and we have the thumbnail image, then we will call the completion handler and pass the image to it. If there is a failure, then we will pass the error a value, the error value, and along with it we will pass nil here, and that's why we have marked it as optional. So this is the tuple, which is the input of the completion handler. Now moving on, the very first operation is the thumbnail URL request. What it does, it takes the ID and it creates the URL to which we will make the API call to and get the data from there. And this thumbnail URL request is a synchronous function. So since we saw this in the diagram, the first and the third is synchronous and the second and fourth is asynchronous. So the second is data task and the fourth is prepare thumbnail are the asynchronous methods, and the first and the third, which is UI image, is synchronous. So all the four operation will happen one by one. The thumbnail URL request will get onto the thread here, and since it's a synchronous method, the thread will start its execution and will finish it, and then control will come back to the fetch thumbnail method, that is the next line after the thumbnail URL request here. So let's move on. Now the second is data task method. So it's a asynchronous method. It will take the request and make the API call. Now this API call will be made, and once we have the API call finished, it will notify us by calling the completion handler with the data response and error in it. So when the data task gets onto the queue, there is one question that arises, that is, since it's a asynchronous operation, it will not block the thread. The thread can suspend this data task method in between and do some other task as well. Before we see that, we will understand that resume here, that is task.resume. What we are doing here is we are resuming the task. And why is there a need to resume the data task method here? Is because in the legacy APIs like data task, the legacy API are the asynchronous function which uses completion handler. And in legacy API, we will have to manually resume the task. So when the data task method, the legacy API or the asynchronous method comes onto the thread, it comes in suspended state. That is, it is one way of telling the thread that I will suspend myself. I know the thread has a lot more important work to do. So the thread should schedule me on its own convenience. And what we do here is we do not put the data task method on the thread in a suspended state. We manually resume it so that the thread can start executing it immediately. Now, this is the case only with the legacy APIs, that is the data task method using the completion handler. It is not the case with the modern APIs where we are using async await to write the asynchronous method. When those asynchronous method comes onto the thread, it will still come into the suspended state, but we don't have to manually resume it. The thread will actually schedule it by its own and execute it. Now, coming back to data task method, it will start executing it, and it can suspend the data task execution in between and do some other task as well. And once the data task method is done making the API call, it has the data, then it will call its completion handler with the data, response, and error. Let's move on and let's see some code for the completion handler, that is the data, response, and error. And this will get onto the thread and the completion handler will get executed by the thread. And that is how a asynchronous function gets executed on a thread. Once we receive the data, response, and error, first we will check if there is an error. If yes, we will call the completion handler of our fetch thumbnail and pass the tuple. The tuple will have nil value for the image and the error value for the error. If the error is not the case, then we will check the following condition, that is if the response is not 200, that means if it's a failure, then we will pass a custom error to the completion handler. And if that is not the case, it means the status code is 200 and we will just use the data to do our third and fourth operation, that is to create the UI image and then use the UI image to prepare a thumbnail out of it. Now let's check out the code for the third and the fourth operation. So the third operation is UI image, where we are using the data to convert the data into the UI image. When this gets onto the thread, it is a synchronous operation. So this is the third operation, which is a synchronous operation. So it will just get executed and the control of the thread will go back to the completion handler of the data task, which is basically, so it basically means that the control of the thread comes to this place. And now the fourth operation will get executed on the thread. So let's see the code for prepare thumbnail. Here, here we are using the image to call the asynchronous method, and this method is having the CG size as the parameter to just convert the image into a smaller image, to which we are calling thumbnail. This is an asynchronous method, so when it gets onto it does not block the thread, and the thread can suspend this method and do some other work as well. Once it is done, it will call the completion handler, that is this one, and will pass the thumbnail to it. We will check if the thumbnail is there. If it is not there, we'll return out of it. If the thumbnail is there, we'll pass it to the completion handler. So our thread will just call the completion handler and with the thumbnail. There is a problem with this code. The first is we forgot to mention completion handler two places. If you have not noticed, in the to guard statement, we have just typed return. In general, developers are very much in practice to write guardlet in a way that we just put the return keyword in the else block. This is not a huge problem. We can still keep this in mind and call the completion handler here as well. So let's fix it by calling the completion handler here as well. Now the bigger problem actually is we are calling the completion handler at multiple places, which is not a good practice. Now the second problem is we are writing too many lines of code for 4 synchronous operation to happen, and we are calling the completion handler at multiple places. That means a possibility for the bugs to creep in since it's hard to follow. Now there are ways to make our code safer by using result type like this, but the problem is it makes our code even large and it is still hard to follow. If you take a look at result type in use, we're just changing the type of the completion handler to result, and when we are calling the completion handler, it makes our code a little bit clean, but the problem is still persist. Now people have been also using the technique like future, that is using the future as the return type. This will eliminate the need for using the completion handler, that is the escaping closure, and it will improve the asynchronous code. But none of these approaches gives us the code that is simple, easy, and safe. And here comes the async await. So in the next video, we will actually write the function using async await. We will be writing the asynchronous function using async await, and this is how the code looks like. We have tackled one of the problem, that is large code. Here it comes down to couple of lines, that is for every operation we are barely writing 2 lines of code, and we don't have to use any completion handler here. So there is the elimination of the problem where we might forget to put a completion handler, and all we have to do is to just throw instead of calling a completion handler with an error. So we will see this in the next video where we are just having the same 4 operations and we're writing the asynchronous function. But here, this time, we will use async await. I hope you find this video informative so far, and I will see